Okay guys, so previously on Engineer Boy, this video was uploaded in Pashto language. In this time, I'm gonna upload this in English language. Where here we got a slab having length equals 7 meter and breadth equals 4 meters. And there are main bars and temperature bar. As you can see in the drawing, we got main bars equals 25 mm at the rate 15 centimeter center to center. Where here 25 mm is the diameter of the bar, you can say, and at 15 centimeter center to center means just the distance between two main bars. And if you look to the temperature bar, these are also known by the distributions bar, okay? Those are 13 mm at the rate 15 centimeter center to center, and there is 2 centimeter concrete core, okay, at each side, you can say. So what if we are asked to determine the steel quantity for the given slab, okay? In this video, we're gonna answer how much steel for the given slab. Okay, so without wasting time, let me go ahead for the solution. And in the solution, I'm gonna do this work in few steps, you can say. Okay, my first step can be the number of steel bars, which I'm gonna calculate is the total distance by center to center plus 1. How it works, where does it come from? We're gonna discuss this little late. Okay, my second step can be the total length, which may be the length of one bar times number of bars, and then just we're gonna add extra length. Okay, in extra length there can be overlap hooks. Okay, we're gonna discuss this little late. All right, my number 3, or you can say the third step, can be the weight of bars, and for which I'm gonna use this formula. Okay, the d square by 162.198 times length of bar. Okay, in MKS system. If you are working in the APS system, of course you can use d square by 52.9 times L. Okay, so the derivation of this formula is also uploaded in the same channel. You can watch that. Okay, the link to that video is down below in the video description. All right, so going ahead in the solution, and in the solution I'm gonna calculate, and I'm gonna do the calculation for the main bar first. Okay, and if you remember that first step, which is the number of main bars, and this time the total distance, which must be 7 meters. Okay, because if you look to the main bars, these are the shorter bar. Okay, these bars, okay, which are just shorter with respect to the other bars. Okay, and as you can see, these divide the length, which is this one, 7 meter. Okay, these main bars divide this side, which is the longest side. So 7 meter divided by center to center, which is known 15 centimeter, or you can say 0.15 meters. Okay, because we're gonna divide that 15 by 100. Okay, because 1 meter equals 100 centimeters. So we're gonna divide that 15 centimeter by 100, which means 0.15 meters. All right, and plus 1. Why we add 1 over here? Because if we divide the total distance by center to center, which can get, of course, the number, and this is gonna start from here. Okay, as you can see, if you look to the cursor, but we provide 1 bar at the start over here. That's why we provide, and we plus 1 over here in the formula. Okay, so the number of main bar can be, of course, 47.67 bars, and which is not a complete value, you can say. We can round it, okay, to a complete figure, you can say, and that is, of course, 48 bars. All right, and then I'm gonna calculate the total length of the main bars, which can be, of course, the length of 1 bar times number of bars plus extra length, and TL. Okay, I'm gonna call the total length equals TL, and that is, of course, the length of 1 bar, which is 4 this time. Okay, and if you can see in the drawing, the breadth of the slab is 4 meter. Okay, which of course just tells us about the length of main bar. Okay, but we're gonna subtract the concrete core to one side and another side. Okay, as you can see, it is given 2 centimeter, or you can say 0.02 meters. So 4 minus 0.02 minus 0.02, this is, of course, 2 times concrete core for one side and another side. So the total length can be 4 minus 2 times concrete core times the number of bars, which are 48 bars. Okay, it's been calculated over there just few seconds ago. And plus extra length, this time as you can see, if you look to the drawings, we are not informed, nothing is given over here about our labs or hooks, okay, and there is no section or long section. So a quantity surveyor is gonna calculate or do all calculation just from the drawings or with respect to drawings, and in the drawing there is no extra length, so we're gonna ignore, you can say, and this can be 0, you can say, okay. So total length can be of course now 190.08 meters, and then we're gonna calculate the weight of main bars, and for this approach of course we can use the same formula, okay, d square by 162.198 times L. All right, so W equals d square. D here is the diameter of bar, which is 25 mm, you can say, for the main bars. So 25 square divided by the same figure times the length, which is of course calculated just few seconds ago, and that is 190.08. So do multiplication with this, we can get of course 732 kg is the weight for the main bars. So this means we're gonna order 722 kg 25 mm bars, okay. And next I'm gonna calculate the temperatures bar, and these are also known by sometime the distributions bar, okay. These are just fixed or provided at the top of main bars. So I'm gonna calculate the number of bars, the number of temperature bars, which is the total distance by center to center plus 1, and that is of course the total distance, okay. If you look to the temperature bar, these guys just divide this side of the slab, okay, just the breadth of the slab, and that is 4 meters, and divided by center to center, that is known 15 centimeter, okay. And the same thing, we're gonna divide 15 centimeter by 100, and that is of course 0.15 meter, okay. And then we're gonna add 1 bar, that is extra bar for the end or for the start. So the number of bars can be 27.67 bars, and again it is not a complete figure, so we're gonna add 1, we're gonna complete this figure, okay, to 28. We can say 28 bars can be provided, okay, as temperature bars. All right, we cannot decrease the value, okay. As you can see, this is 27 bars. We can't say 27 because if we decrease the value, there can be a huge spacing between 2 bars, okay. So that's why we're gonna increase the value to 28 just to overcome those you can say contingencies. So the number of temperature bars are now 28 bars, and then we're gonna calculate the total length of temperatures bar, and the same formula can be used as we did for the main bars. So TL equals the length of 1 bar. This can be 7 meter, okay. If you look to this side, okay, and these are temperature bars, so these are 7 meters, but we're gonna subtract 2 times concrete core for one side and for another side, and that is 2 centimeter. All right, now times number of bars, those are 28 bars plus extra length. There is no extra length, okay, because we can have 7 meter lengthy bar, okay, in the market, or we can order 7 meter lengthy bar, okay, from the market. There is nothing mentioned in the drawing about overlaps or hooks or about extra length, okay. So this can be 0. So the total length is now 194.88 meters, and the same formula can be used for the weight, okay, d square divided by blah 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 blah. All right, so W equals d square. This time we got 13 mm as dia bar, so 13 square divided by the same figure times the length, which is known 194.88 meters, and that is of course 203 kg. All right, so the final results are here. We're gonna order 722 kg 25 mm bars and 203 kg 13 mm bars. That's it. Hey, if you like these types videos, please hit that subscribe button, press the bell icon, and never miss an update from Engineer Boy.